guys can see this? Okay, great.
Hello, we are Team Columbia, and we made a toxic comment identifier. So this is our website. So some goals for this product is to help stop cyberbullying, mitigate identity hate, and to prevent online profanity.
So just a quick demo of our product. So you can type in any type of offensive text. We're just going to keep it kid-friendly over here. And I'm going to just type in something like, I hate you. And once we generate this piece of text, what's going to happen is we're going to just get a percentage of like a classification as to how this text would fit in. So we have 79% being toxic, 21% being insult, 9% being obscene, and then so on.
Okay, so why is this so important? Well, as we all know, online harassment may result in depression, drug usage, and a significant risk of suicide. And as you can see, the future is pretty bleak with hate speech. So if it isn't stopped right away, it might turn into a habit with significant legal implications. And as these statistics become progressively worse, our group felt the need to stop this critical problem, which is exactly why we've designed a tool to help flag exclusionary messages.
We took many steps in order to create this project. The first step was to collect data. There were several different Kaggle datasets to choose from, and ultimately we went with the Kaggle Jigsaw dataset.
Another vital part of our product was Birch, a pre-trained transformer model made up of encoder blocks, which we use to extract word embeddings, which are the ways computers understand individual words, as well as to gain an overall understanding of the input sentence.
For step 3, we pre-process our data using built-in Birch features, which includes tokenizers and a lowercase converter, as well as NLTK's word tokenizer and stop word remover. To train our model, we did 2 different run-throughs, one with only the Birch features and then the other one with both. Ultimately, we decided to go with both Birch and NLTK to pre-process our final product. And then for step 5, we evaluated our model on a train test split method with an 80-20 ratio, as well as our own intuition to gauge the accuracy of the model's outputs. Lastly, we performed some quick post-processing in order to classify the labels from most to least relevant, as well as rounding the decimals to the hundreds, just to increase the readability of our results.
And step 6 is to create a website to show all of our hard work. And finally, step 7 is to share our audience, which is what we're doing right now.
So in any product, there is nothing, it's not a product without any difficulties. So we had 4 main difficulties. I'm going to go ahead and present one of them. And during our web development, we encountered a difficulty in which whenever we wrote any piece of text on our website, and what would happen is that that piece of text wouldn't properly save. So the next moment we entered our website again, it would just, the whole text would basically be gone. So what we did is that we experimented on a Google Doc and then transferred that piece of text to the website, and we saw that it was successful.
This is just a little bit more in-depth information about Birch.
Our dataset had comments that were classified into 6 different categories: toxic, severe toxic, threat, insult, identity hate, and obscene. If the comment fell under none of these categories, it is considered clean. As displayed by this pie chart, most of the 159,571 comments that our data was trained on fell into none of these 6 categories. Only 10% of all the comments had any level of toxicity. These 2 graphs up above depict our data distribution and represent how many comments were labeled as toxic versus severe toxic, and so forth. A majority of the 10% of our comments that fell into a category of hate were toxic comments, obscene comments, or insults, while comparatively fewer comments fell under the classification of severe toxic, identity hate, or threats. Finally, this 3rd bar graph shows that many of our comments had multiple labels. For example, a certain comment might be both a threat and an insult, so it would have 2 labels.
BERT's output, which contains the understanding of the input sentence, was then passed on to a basic linear classifier. Sorry, could you scroll down? A basic linear classifier, and then a sigmoid function, which is what allowed us to show the probability that the input comment falls into whichever one of those 6 categories or multiple.
Yeah, and this is our team.
I'm Bella, and I worked on the web development.
I'm Elisa. I worked on web development as well.
I'm Kimberly, and I also worked on the web development.
I'm Rachel, and I worked on some of the code for the data processing.
I'm Shreeya, and I worked on data visualization.
And Justin was our amazing instructor. Thank you for tuning into our presentation.
Wow.